Hello, IB Math. Well, it's Tuesday, March 3rd, and if you're watching this video, then that means I didn't make it back when I was hoping to. I'm going to need at least another week for whatever reason. But as you can see from the rest of this chapter so far, not so bad. Pretty good stuff. Today we're going to see a little bit more detailed things. But we'll see a lot of things that are on the calculator, and we'll get a calculator to do a lot of the work for us. You have to know what the symbols are, what the symbols mean, and they're going to ask you about the symbols. But really, when it comes to actually doing the calculations, everything is just as easy as entering everything into the lists in the calculator, and you can do it on the TI or on the Casio, and then getting the calculator to do all of the work for us. So today we're going to talk about justification of the statistical different techniques. All right, here we go. Okay, so one of the first things that I want to talk about today is something that should be kind of familiar to us, the box and whisker diagrams. And we've seen these lots of different ways, been seeing them from very early on, but they have a much more important application, as we'll see, a box and whisker. A typical box and whisker, and what I'd like to do is I'd like to just kind of draw a box and whisker, and I'm going to use grades. And let's say on a particular test, we're going to create a box and whisker representing the test grades. So we're going to have the lowest test grade here going all the way up to the highest test grade here. And let's say the lowest test grade was a 52 and the highest was a 95. So we need to evenly distribute things here. So, oh gosh, let's see, 52, what's that, 62, 72, 82, 92, 52, 62, 72, 82, 92, something like that. It all has to be even. And let's say that the median was an 81. So 52, 62, 72, 82. So let's say right around here was the median grade, the middle grade, which was, so the median grade, which was an 81. And then we have the other quartiles, the boxes around that. And let's say we had an 86, so 82, 92, so let's say something like 86 here, and a 72, 52, 62, 72, something like this right here, 72. And these are, we should remember these as the different quartiles, quartiles 1 and quartile 3. And actually, the low grade is really quartile 0. The median is really quartile 2, and the high is really quartile 4. Weirdly enough, this is sometimes called the 5-quartile array, the box and whisker, and it can be written as an array of numbers. We could write it as 52, 72, 81, 86, 95. Kind of a 1, 2, 3, 4, 5 quartile array, a list of numbers. This is a box and whisker. Notice the box and whisker also is drawn to scale. The low grade, the median grade, the high grade. Quartile 1 is the median of the low half. Quartile 2 is the median of the high half. And each of these different areas represents 25% of my data. So between quartile 0 and quartile 1, 25% of my data is here. Between quartile 1 and the median is 25% of my data. So 50% of my students scored between 52 and 81. 25% of my data here and 25% of my data here. So there's the same number of students that scored between a 52 and a 72 as between an 81 and an 86, even though that's a bigger range of numbers. 25%, 25%, 25%, 25%. And of course, if I take the low minus the high, this whole distance right here, we call that the range. So from here to here would be the range of values. And we're beginning to see some of these numbers, medium, high, low. Now, where would the mean, the arithmetic mean, the average be? Where would the mode be? Well, they could be in lots of different places here. The mean could be at the median. It could be less than the median. It could be greater than the median. The mode, the most frequently occurring, again, who knows? That could be anywhere there. That has to deal with more of the kind of the shape of the distribution, something called the normal curve here. So, typical box and whisker, 5 quartile array, the lowest, the highest, the median, the other quartiles, and the range. Now, notice what I am not telling you here is how many people took the test. Was there 50 people, 100 people, 20 people took the test? You don't know. You don't know. You know the lowest score and the highest score and the middle score and the quartile 1 and quartile 3. And this is the interquartile range, just as this is the total range here. If I just did from here, this is the interquartile range. Interquartile, oh, it's getting small and all messed up there. I'm sorry. Interquartile range would be just Q3 minus Q1, where the whole range is Q4 minus Q sub 0. So we've kind of seen all of these before, kind of looking at it. We're going to be a little bit more detailed in talking about these things. When we're looking at these box and whiskers, we're looking at the minimum value, the first quartile, the second quartile, which is the median, the third quartile, and then the fourth quartile, which is the maximum. Box and whisker is the diagram. Oh, sometimes called a box plot. These are often referred to as box plots as well. Or we can just write it as an array, a 5 quartile array of numbers. Now, sometimes we get a number that's way outside of our data set. We have a special name for that and a special calculation for that. That's just something we would call an outlier. An outlier is a piece of data that is very far from all of the other data. It's way out of the range of all of the other data. And this could be due to an error in collecting the data, or it could be just, somebody had a really bad day that day taking a test, or there just happens to be one data point way out of range of all the others. Now, in the outlier, we often jumps out at us as being so far away from everything else. But there's actually a calculation that we need to know in order to find the outlier. So let's be specific about what exactly is an outlier defined as. All right, an outlier is defined as a data item Oh, my handwriting's not so good today. Sorry. A data item which is more than one and a half times the interquartile range. One and a half times the interquartile range from what? Below the lower quartile or above the upper quartile? Below the lower quartile or above the upper quartile. So this might represent somebody, for example, on a test that did really badly. They got a 22, and if the interquartile range was what was the interquartile range on that last one there? From 72 to 86, the interquartile range was 14. So double 14, 1.5 times 14 would be 21. So if they were 21 points below quartile 1, which was a 72, or 21 points above quartile 3, which was the 86 on the previous example, then they would classify as an outlier. It would be one that was statistically far above or below. And it would actually classify as an outlier of the data. All right, well, using range and quartiles are good measures of spreads. So talking about range and the quartiles are good measures of the spreads of data. Now remember, we talked about measures of central tendency, how close things tend to be around the mean, measures like mean, median, mode, and mid-range, and then measures of spread, like range and quartiles and things like that. But they don't take into account everything. There's two other measures that we really need to get familiar with and that we're going to start talking about. Two new words. The new words are variance and standard deviation. Variance and standard deviation are combine all the different data values in the data set, and they give a much better measure of the data spread about the mean, better than the range and the quartiles, and even because they take into account the outliers. Standard deviation is a measure of how far, on average, each data value is from the mean. The calculations for variance and standard deviation can be a little bit cumbersome. There's a really good example that I want you to take a look at. I'm going to talk about the formulas here in a moment. And then there's an example that I want you to look at in your textbook. And when it comes to doing them by hand, I don't want to do them by hand. We're going to do an example here in a little bit, and we're going to just do everything on the calculator. So first, here's the scary formulas. So for standard deviation, okay, here comes some crazy symbols. So standard deviation is going to be our lowercase sigma here. And I should make a note that this is for the entire population. This is standard deviation for the entire population. Later we'll talk about standard deviation of a sample. And we'll use a slightly different formula, a slightly different symbol here. But this is standard deviation for entire population. And it is the square root of, here it comes the craziness, the sum, we know the sigma there is sum, from I equals 1 to n of, so we're adding something up. What are we adding up? X minus the data points squared. So the x there is the mean minus the data points squared. Each of the data points minus the mean squared. X is the data point minus the mu here is the mean squared. And that's all divided by the number, and it's the whole square root there. So adding up all of the data point minus the means squared, so this is a bunch of positive numbers we're going to be adding up because it's squaring. Sometimes the data point might be less than the mean, the average. Sometimes the data point might be more than the average. So you get positive and negative numbers in here, square them, add them all up, and divide by how many they are. That is the standard deviation of the population. And standard deviation gives a mean average, kind of an average, if you will, of the distance between each data point and the mean. Next we have variation, or variance. And again, I'm going to talk about variance of the entire population. Later, when we're talking about samples, and we're taking a sample and we're finding standard deviation of our sample, standard deviation of, or the variance of our sample, we'll use slightly different formulas, slightly different symbols here. It's going to be the standard deviation squared. So as you can imagine, we're just going to get rid of the square root thing here. So it's going to be the sum from I equals 1 to n of each data point minus the mean squared all over the number of data points. That's the population variance. And these numbers give us a much better idea on the spread of the data. And we'll see these, and we'll talk about the meaning of these numbers. First, we're going to talk about calculating them. How do you find these numbers? And then that part, at first, a little confusing. And then later, we'll rely on our calculator to do all that, the crazy work for us. And then we'll talk about, well, what does this mean? What's going on here? What I'd like you to do at some point is I want you to take a look in the textbook on page 337, example number 7. I want you to look over that. You don't have to write it and put it in your notes, but I just want you to look at it. And what it talks about is a group of 40 students were asked, how many times did you visit the dentist last year? And then you've got their responses. So you've got 40 numbers. And the numbers could range from 0, they didn't go to the dentist at all, up into, I think the highest number, somebody went to the dentist like 8 times last year or whatever. But you've got a whole bunch of different responses from 0 to 8. And what the textbook does is it goes through the calculation for standard deviation and variance by hand. It does it all by hand. So it shows you what the data points are, what the mean is, the difference between the data points and the mean, and then they square it, and then they added them all up, and then they divide them by how many data points there were, and in this case there were 40. And they actually do everything by hand to find the calculations. But like I said, doing it by hand is too cumbersome. We don't want to do it by hand. So let's take a look at 2 examples now where we're going to get the calculator to do all the work for us. In the first example, just a relatively small data set, we're going to use the numbers 2, 6, 7, 5, and 4. Just a couple of nice, quick, little, easy numbers here. Just 5 different numbers, so my n is going to be 5. And what I want to do here is I want to find the mean, the median, the mode, the standard deviation, and then we're going to mess around with this data set and see what happens when we mess with the data set. And of course, I'd like to do everything on the calculator here. So go ahead and take out your calculators. And again, I realize that the calculator isn't the best on the overhead, and I'm sorry about that. Or I kind of have to just deal with this as best as we can. And I want to do everything on the calculator here. So we're going to go to, now this will work on the Casios as well. You can do everything on the Casios. Oh dear, a bunch of junk on there. I forgot about that. Going to go to Stat and edit where our lists are. On the TI, going to go to Stat and edit the lists. Oh, I've got a bunch of junk in there. Go to Second Plus, which is your memory manager. Go down to Clear All Lists. Hit Enter. Now I'm going to go back to Stat and edit. There are all my lists. Go to Menu and Stat, there are my lists. So it's going to be very similar on both calculators at this point, just entering it and doing all the data on the calculator. I'm going to focus on the TI here. So the first thing is just entering the data. Now you'll notice we've only really got one set of data here. So I'm going to enter 2, 6, 7, 5, and 4. Just everything in list 1. I know it's kind of hard to see. I can't zoom in and zoom out when I'm actually recording, but so here we go. So 2, 6, 7, 5, and 4. And enter that into the calculator. You might want to pause the video, make sure that everybody's got that entered into the calculator, because everything happens pretty fast after this. The next thing we're going to do is we're going to get the calculator to do all the work for us. Here's how we're going to do this. We're going to go to Stat, and then we're going to go over to Calculate, and I want to do one variable statistics. I really can't do a linear regression because there's no two sets of data here. So one variable statistics, hit Enter, hit Calculate, boom, there it is. Now notice there's a little arrow here. I can use my up and down arrows. Same thing on the Casios. Be careful, if I start typing, I won't be able to do that anymore. But look at the data that it's given me. First it tells me X bar equals 4.8. And X bar, we should know that that means the mean. The little sigma X, the sum of all the X's is 24. If I add them up, it's all 24. The sums squared are 138. S of X is 1.923. That's S of X, 1.9235, whatever. That's my standard deviation. And if I look at that squared, that would be my variance. Now I'm going to use the down arrows here. You can see n equals 5. I'm using my down arrows. Now notice it's telling me n is 5. There were 5 pieces of data. Minimum is 2. Quartile 1 is 3. Median was 5. Quartile 3 was 6.7. And the max was 7. So if I wrote this as an array, I would have it as 2, 3, 5, 6.5, and 7. Those are my quartiles. And if I wanted to create a box and whisker, and the calculator will do box and whiskers as well, second plus equals, turn my scat plots on, and here I'm going to go to box and whiskers right here. And if you're not following this, this is okay. We'll be able to do this just from this array here in a moment. And then zoom stat. And there I've got my box and whisker. Oh, it looks like I've got something, a line in there. Yep, sure enough, clear that line out of there. And there I've got my little box and whisker. But I could do this quite easily. 2, 3, 4, 5, 6, 7. Remember, I want to evenly spread things out. My low is a 2. My high is a 7. My median, the middle number, was a 5. And then quartile 1 was a 3. And quartile 3 was a 6.5. So there it is. And I could change my window and get a better view of it here if I wanted to. But there it is. There's everything that I wanted to do. All right. Let's do another example now. A little bit more involved, a little bit more difficult. In the next example, I want to look at a much bigger data set. And again, I want to kind of do the mean, median, mode, mid-range, interquartile range, and I want to explore the idea of outliers. So for this data set, what I'd like to look at is how many text messages were sent last Monday. And I'm going to pick 15 students by 15 students. So So how many text messages were sent last Monday by 15 students? So I'm going to go around, pick 15 students, and I'm going to say, well, how many text messages did you send? And then I'm going to record the data here. So we can see that this data is going to be a much bigger data set. All right, so here we go. Here come the numbers. First student said they sent 36. Another said 40. Another said 12. Another said 0. 15. 25. Another one said 25. 78. 45. 28. 18. 3, 15, 19, and 20. Now that should be 15 students. Let me just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Perfect. I got all 15 students there. So we've got our raw data. Now notice we don't have to put the data in order. We don't have to do anything special with it in order to do the complete all the information about this. So I'm going to go back to my calculator. I'm going to go back to my stats. I'm going to go back to my lists. Oh, there's a bunch of junk in there. You can type over it, or if I go to second plus, my memory manager, clear all the lists out of there. It'll clear all the lists. Now when I go back into stat and edit my lists, there it all is. All right? And I can type all over it. So now I'm just going to type the raw data in list 1. So 36, 40, 12, 0, 15, 25, 25, 78, 45, 28, 18, 3, 15, 19, 20. I know I did that kind of fast. Again, you might want to pause the video. One of the things that I always do before I start doing any of the calculations is I go back and I check my data, because if you put in something wrong, everything's going to be wrong. So definitely check it. So let me see. 36, 40, and 12, and 0, 15, those two 25s, 78, 45, 28, 18, 3, 15, 19, and 20. And really, this is the hardest part of the problem. Make sure you've got all the data that's in there and everything's in there correctly. All right, so once all the data is in there, the calculator is now going to do all of the work for us. All right, so here we go. We're going to go to Stat, Calculate, One Variable Statistics, using List 1, Calculate, and here it is. There's everything we need to know. So as I take a closer look and I write down all my information, it's telling me that the mean is 25.26 repeating. So a little over 25 texts is the average number of texts that are being sent. My standard deviation is sigma is 18.53. We'll talk more about what does that mean as far as the spread goes and what's that calculation used for. N is 15. That's good. There were 15 people there. Using the down arrow, I can see that my quartiles, my minimum was a 0. Quartile 1 was 15. The median was 20. Quartile 3 was 36. And the maximum was 78. All right, so now let's put all this together and answer a bunch of questions about this. First, I'm going to create a box and whisker. Where'd that green pen go? I'm going to use a green pen here. So let's see. So my box and whisker. So 0, 10, 20, 30, 40, 50, 60, 70, 80. So 0, 10, 20, 30, 40, 50, 60, 70, 80. I know it's not very nice and straight. Obviously if we were doing it, we would probably want to do a better job of it, nice and straight. I know my low was 0, so there's quartile 1. My high was 78, which is right about here. All my data happened between 0 and 78. My median was 20, so right about here, there's my median of 20. Quartile 1 was 15, so 15, and quartile 3 was 36. All right, so here we have our detailed box and whisker. Now, let's answer some questions about this. The mean was, what did we say, 25.3-ish. The median, we haven't talked about some of the other numbers here. How about the median? Well, we know that that was 20. Was there a mode? Did my calculator give me a mode? I'm going to use the up and down arrow. I thought that there was a mode in here. It should tell me the mode. I don't know why the mode's not on there. The mode, 25 occurred more than once, didn't it? So I think I have a modal value here of 25. What about my interquartile range, my IQR? My interquartile range. Well, that's going to be the 36 minus 15, which is 21. So my interquartile range was 21 there. Now let's see. Do I have any outliers here? Well, this is going to be a little bit interesting. Let's take my interquartile range. So my interquartile range was 21. 21 times 1.5, remember 1.5 times 21 is 21, and 10.5 would be 31.5. So I'm curious, do I have any numbers that are greater than 31.5 or less than 31.5 from the lowest point? Well, the lowest here was 15, so I'm definitely not going to have any that are outliers below that. But here I had 36. 36 plus 31.5 is 67.5. I had a couple of more bigger than that. So 67.5, 67.5, do you see how I got 67.5? I took my quartile 3, 36, added it to 1.5 times my interquartile range, and got my 67.5, and I do have numbers bigger than that. How many numbers do I have? 78. So therefore, 78 is an outlier. That 78 was definitely an outlier. It was more than 1.5 interquartile ranges away from my maximum or my minimum. All right. Well, hopefully that kind of clears the things up. Don't get scared about all of the different crazy symbols. And like I said, we'll be focusing a lot and doing most of the stuff on the calculator and getting the calculator to do the work for us. We need to be aware of the symbols and how to get these calculations. But when it comes actually down to doing it, we'll be able to do everything on our calculators. All right, I think you're ready now for the next assignment. So we're going to go ahead and do assignment 5F. So do assignment 5F, and we're going to go ahead and move on to the next video here and continue looking at randomness and kind of analyzing data and quantifying our randomness.